First thing we're going to do, we're going to expand the bracket with x. We're going to get x plus x squared. We'll find the first derivative of x plus x squared, and we're going to equate it at 0. We are equating y to 0 because we're going to find the critical point, and the critical point will give us our minimum point. Yes, that's the minimum point for x, which we are going to plug in back into our expanded equation, and then we are going to get our minimum value. But meanwhile, we'll also get the turning point, which is the second derivative, to ensure that the second derivative is greater than 0, that is positive. So first off, let's expand. So alright, solution. So expansion of x divided by 1 plus x, that's x plus x squared, right? So this is equal to y. So as we did before, when we have the y by the x of two separate entities containing x, first off, the formula we did from question 3. So here, let's just do that. We're going to have this is equals to 2x plus 1. Alright, so 2x plus 1. Remember we said we will equate this to 0. So this is equals to 0. 2x plus 1 equals to 0. So we have that 2x is now equivalent to minus 1. If you collect like terms, 1 comes over to the other side. So divide both sides by 2. X is equivalent to minus half. Now, minus half now is our minimum point, but we need to ensure this by making sure that y is greater than 0 at the turning point. Alright, so to get the turning point, we'll find the second derivative of this. So remember, second derivative is d square y over dx square, alright, of 2x plus 1, the x of 2x plus 1. So this is equivalent to 2. So 2 is greater than 0, so meaning that minus half is our minimum point, and we used to get our minimum value. Minus half is our minimum point. Alright, now plugging minus half into the original equation itself, which is x plus x squared, we have that y, the minimum value we are going to get now, will give us minus half all squared, alright, plus minus half. And this half all squared is, this is equals to, let me start here, minus half all squared is equals to 1 over 4, minus half plus minus half, that's minus 1 over 2. Alright, we're going to take LCM, so LCM becomes 4, this is 1 minus 2, so 1 minus 2 is equivalent to minus 1, so minus 1 over 4 is our final answer. Correct answer is option A. Question 5. If s is equals to 2 plus 3t multiplied by 5t minus 4, find the s over dt when t is equal to 2 seconds. So how are we going to solve this? First, we're going to multiply 2 plus 3t by 5t minus 4. That's expansion using the Fourier method. We're going to find the first derivative of that expression. That's the s over dt. Then what we'll get, we're going to substitute 2 into that expression. First, let's expand. So we'll go solution. 2 plus 3t multiplied by 5t minus 4. 2 multiplies 5t. Okay, let me just write it again. 2 plus 3t, we have multiplied 5t minus 4. 2 multiplied by 5t, that's 10t. 2 times 5 is 10. 2 multiplied by minus 4, that's minus 8. 3c multiplied by 5t, that's 15t square. 3t multiplied by minus 4, that's minus 12t. Okay, we're going to multiply 10t minus 12t. Those are common, right? So you can measure them together by just subtracting. So we have here 15t square minus 2t minus 8. So this is equals to x. Instead of finding ds over dt, that's differentiating s respect to t. We're going to differentiate this using the same formula that we did for question 1 and question 3. First off, for 15 multiplied by 2, that is equals to 30t minus power here is 1, 1 minus 1 is 0, so we have 1 times 2, so that's 2. So 30t minus 2, that's the first derivative of this expression. 2 plus 3t, 5 minus 4. Now we're going to replace our value of 2. So we'll have that when t is equals to 2, ds over dt now becomes 30 multiplied by 2 minus 2. 10 multiplied by 2 is 60. If you remove 2 from 60, that's 58. So the answer is 58 units per seconds, which is option E.